Good evening, everyone.
Good evening, ma'am.
Good evening. Okay.
Good evening, madam.
So today is week 8. So anyone have watched the week 8 lectures?
Yes, ma'am.
Anusha, you're having any doubt with the
Yes, ma'am.
question?
I was doing a PYQ question
Hmm.
and I solved it. I used the right logic, but still the answer was alright. Can I
Okay,
send
fine.
you the link to the paper?
Yeah, you can send me the question, but I will be solving that question after the
Sure,
session.
sure, ma'am.
Fine?
Sure.
Yeah.
Fine.
Okay then.
Thank you.
So okay then. So let's start with the shall we start with the session now?
Sure, ma'am.
Okay then. So in week 8, we are actually learning about the conditional distribution. Okay. So first of all, the in previous lectures and all in previous weeks, we learned about like sample space, then we have random experiments and everything. And the first thing is like we learned about which was relative frequency, if you guys remember. Do you remember what is relative frequency?
Ma'am, it's the respective frequency over total frequency.
Yeah, we can say the respective frequency upon the total frequency. And you guys remember the contingency table,
Yes, ma'am.
right? Which was basically to we can say that to summarize or like represent the data in a more 2 into 2 table, right? Okay, then. So let's take that example only in which we are calculating the association between the ownership of smartphone and gender. Okay. So basically let's make the table here. Okay. So this is the ownership. Okay. So whether he is buying or he's having or he's not having. Then we have the gender preferences also. So we would be having female and we are having male. Okay. Now the counts are like 34, 40, 10, 13. This is my total column total, which will be 76, 24. This is my row total, which will be 44, 56. And this is the whole total, which is 100. Okay. Now, if I have to calculate I'm not calculating the row relative frequency or column relative frequency. I'm simply calculating the relative frequency. So if I have to calculate the relative frequency, I would be dividing this frequency by the total frequency, which is 100. This is my total, right? Total frequency. So I would be dividing my frequency with the with the total frequency, correct?
Yes, ma'am. Yes, ma'am.
Similarly, for this one also, 10 divided by 100. This would be 42 divided by 100. This would be, so this is my respective relative frequency, correct? Okay.
Yes,
Now,
yes.
now this is basically equal to 0.34. If I write it like this, it would be 0.34. This would be 0.42. Like that, we can write it that this would be 0.1, 0.14, 0.44, 0.56, 0.76, and 0.24. Okay. Now, what can you say about this value?
It's 34% of the of the total owners are females who have smartphones, right?
Yeah, so we can say it is you can say that this is the probability that the number of females who are owning a smartphone. Correct? This is my probability. Okay. Now, if I have to calculate the marginal probabilities, so if I have to calculate the marginal probabilities of female, it would be equal to, if I have to calculate the marginal probability of female, it would be this plus this.
Yes, ma'am.
So this would be equal to 0.34 plus 0.10, which will be equal to 0.44.
Yeah.
Correct. So basically, if you see here, these value, this value, this value, and this value, these are my four marginal probabilities. So basically, this is my probability of female, this is my probability of male, this is my probability of the people who are owning a smartphone, and this is the probability who are not owning a smartphone. Correct?
Yes, ma'am.
Okay. Now, if I have to calculate, like the question is, if I have to calculate among female buyers, okay, among female buyers, what is the chance that someone will own a smartphone?
Ma'am, so this is where conditional probability comes in.
Yeah, correct. So
Oh.
here we, so what do you mean by conditional probability?
Ma'am, like it's based on a certain event occurring first. Like in here, what is the probability among few? That is the condition.
Yeah. So here we are beforehand we have been specified that these are the female buyers. Then the next situation is like if we are given that they are the female buyers, so what is the probability that they will own a smartphone? So this is my previous condition. On the basis of this previous condition, we have to find out this probability. So that is basically my conditional probability. So if I have to calculate this value, this would be equal to what? This is basically my row relative frequency, na?
Yes, ma'am.
Okay. So what is this value?
0.34. 0.34, right, ma'am?
No. See, so basically this was if I just change the number.
Oh, no, ma'am. It will be 0.34
Okay.
divided by 44.
This is 34 and 10. This
So
was
it will be
42.
34 over 44.
Yeah. So we would be looking into this row only, right? Among the female buyers. So my total is 44, correct?
Yes, ma'am.
So this is 44 and who are owning a smartphone, it is 34, correct? So this would be equal to 34 by 44. Is it fine?
Yes, ma'am.
Yes, we are just finding the row relative frequency right here.
Yeah, basically we are finding out the row relative frequency. So in earlier cases, we were finding out row relative frequency, but now it is basically my conditional probability. So like in short, what is a conditional probability? It is basically like we determine the probability when some partial information is given. So actually this among female buyers, this is my partial information. Okay. Now we have to find out this probability. We have to find out this probability with the partial information that we have been given. So this is basically my conditional probability. Got my point?
Yes, ma'am.
Okay. So like, so let's say I'm having an event E, some event E, and it is like some event E is given. Okay. And one another event is given, which is actually the event that has been done. Okay. This is my partial information. So you have to find out the probability of E given F.
Given F, yeah.
It would
So
be
that
equal to probability of E intersection
intersection
F upon
by P
probability
of
of F.
F. Yeah.
Okay. And the condition is the probability of F should be greater than 0. Okay. Okay. Now let's take an example. Okay. So let's say I am tossing, I'm rolling a dice twice. Okay. So what are my sample spaces? It would be 1, 1, 1, 2, 1, 3, 1, 4, similarly 1, 6, correct?
You have 36 members in the sample space.
Yeah, we would be having 36 samples. Okay, so this would be similarly till 2 comma 6. Then we would be having 6 comma 1 till 6 comma 6. So in total, we are having 36 samples here. Okay, now the question is, like, I am denoting my events. So my E is denoting that the sum of the die is 10, and F is denoting that the first die is 4. Okay, so so we have to find out, if you have to find out, let's say, uh just a second. Okay, so so this is my example. So my, like, if I'm rolling a dice twice, so I am having an event E, which is the sum is 10, and F is that the first die lands is 4. So my question is, if I have to find out that the sum of the pair of rolling dice is 10, given that the first die should be 4.
Yeah, so my P of E should be 3 by 36, right?
Probability of E.
E.
See, I have to find out. See, I am asking, like, you have to find out the probability that the sum of pair of rolling dice is 10, given that the first die
Oh, I see.
lands on
Hmm.
4. So basically, you have to find out probability of E given F.
Yeah. Okay,
Okay,
that would be
so
intersection. That I
yeah,
need
so
to
this
find.
would be intersection of F upon probability of F. Okay, now let's find out the numerator and the denominator. So probability of E intersection F. That means my first die is 4, and
Yeah.
the E is that the sum should be 10. So what are my
Yes.
cases? There is only one
There are
case, that
only
is
one. Yeah.
4 comma
4, 6,
6.
6.
So what is
Right.
the probability of 4 comma 6? It would be equal to
1 by 36.
1 by 36. Okay. Now, probability of F, which is basically that the first die is 4. So what are the
4.
cases? 4 comma 1, 4 comma 2,
It's
4
6
comma
by
3.
36.
Yeah, so basically 4 comma 6. So basically I'm having 6 samples. So the probability will be 6 by 36, which is 1 by 36 only.
Yeah, no, 1 by 6.
Sorry, 1 by 6. 1 by 6. Okay, now put these value into this formula. So it would be equal to 1 by 36 divided by 6 by, you can say 6 by 36, which will be
It's 1
equal
by
to 1
6
by
only.
6. Got it? So this is my conditional probability, and this is my conditional formula. Got my point?
Yes.
Is it fine? Is the conditional probability clear to everyone?
Yes, ma'am.
Okay. Now, the second thing is we have multiplication rule. Okay. So in conditional probability, we had probability of E given F is equals to probability of E intersection F divided by probability of. Correct? Now, if I multiply both the side by probability of F, okay, both the side I'm multiplying probability of F, both the side. So this will get cancelled. So I would be getting probability of E intersection F into probability of F equals to probability of E intersection F. Correct? So actually, this is my multiplication rule. Okay, which states that the probability that both E and F will occur will be equal to the probability that the F occurs multiplied by the conditional probability of E given F. Got it? This is my multiplication rule. It is just simple. If you see in this conditional probability formula also, this formula, if I just put this probability of F here. If I multiply here, this would be the same condition. Any doubts or any confusion?
No, ma'am.
Is this fine? Is this multiplication rule fine? This formula? Anybody having any doubts? Like nobody's saying anything, so
No, ma'am, we're fine. I'm fine.
we are fine. Okay. So let's say, let's take one example. Just a second. Just a second. Let me take one example from the activity only. I'm taking an example. Okay. So we are having. So the question is, we are having a box in which I have 8 white balls. Okay, and 4 black balls. Right? Now, 2 balls are drawn at random, one after the other, without replacement. So we have to find out the probability that both the balls drawn are black. Like the 2 of them should be black. This is my case. And I'm drawing it without replacement. Is the question clear to everyone?
Ma'am.
Okay. So actually my formula is probability of E intersection F equals to probability of E given F. This is my multiplication rule. Okay. So according to this question, I'm having 8 white balls, 4 black balls. I'm drawing out two balls independently without replacement. And the question is, I have to find out the probability that both the balls drawn are black. Okay. So let's see. So the first condition is I'm drawing a black ball. Okay. So in total, how many balls are there?
12.
There are 12 balls. Okay. Okay. So if I draw first ball and it should be a black. So what is the probability of getting black ball?
4 by 12.
It would be 4 by 12. And now I'm drawing out the second ball. Okay. So the first thing is I'm drawing it individually. So in the first draw only, I have I've got the black ball. So in the second draw, what is the probability of getting the black ball?
3 by 11.
3 by, it would be 3 by 11. Correct. Okay. So now if I have to calculate the total probability, what will it be? It would be probability of the black ball getting in the first draw, multiply the probability of getting the ball in the second draw. Correct?
Yes, ma'am.
Okay. So it would be 4 by 12 into 3 by 11. So this is basically 1 by 11.
Yes, ma'am. Got it.
Okay. So this equation, what it states that. So it is basically, this is basically probability of getting a ball, black ball, into probability of getting, let's say, okay, this is a probability of getting black ball in the first toss. Then in the second toss, the probability of getting a black ball, given that I have gotten a black ball in the first toss. So this is basically equal to this formula only. So we are just finding out the value, the conditional probability only. Got my point?
Just have one question about this. So, can't we do this thing that since we have the total balls and among those white balls are 8 and black balls are 4, so we could choose 2 balls from those 8 balls at the first instance only. So let's say 4C2 would be my choice from in the first time itself. So we could have gone for 4C2 by 12C2, right?
Okay.
So should it be should it be going right in the same direction?
4C2 and divided by 12C2.
Yeah.
Maybe I'll find out that. Yeah, we can do it like that also.
Yeah, because essentially we are practically choosing balls, right? So we could have done like 4C2 in the first time itself. So 4C2 would have given us the favorable outcome in first in place. And the second place, so the total number of balls is 12. So the total number of balls that we are going to choose is 2. So 4C2 by 12C2.
Yeah, you're applying
Right.
the combination. Yeah, you can do that. But here we are just taking this case like in general, like we are taking this multiplication rule. So with that, we are solving the question.
Okay.
You
Okay.
can do it like that also. So the thing is like you will be having different approaches, but the answer should be same. That's the main point. Okay.
Okay.
Okay. So this is basically my multiplication rule. Okay. And this can be generalized for if I'm having n number of events. Okay. So if I'm having n number of events, let's say if I have to find out the probability of E1 intersection E2 intersection E3 intersection En, this would be equal to probability of E1 into probability of E2 given E1 into probability of E3 given E1 intersection E2. This will go on till probability of En given E1 intersection E2 intersection En minus 1. Is this formula clear to everyone?
Yes.
Can you relate this can you relate this formula, like this formula with this question? Everyone? So
Yes.
here we are like the first, if you say here, the first event is taking out a black ball, okay, in the first draw. And second event is taking out a black ball in the second draw. So if I have to find out probability of E1 intersection E2, right? So this would be equal to probability of E1 intersection E2 would be equal to probability of E1 into probability of E2 given E1. So if you state this, so this is the probability of getting black ball in the first draw. This is the probability of getting a second ball, black ball in the second draw, given that one black ball is already drawn in the first draw. Got it? It is now clear? Like the question is clear? How to
repeat the last point?
Sorry?
Could you once repeat the last point?
This one?
Yes, ma'am. The
Okay.
statement which you were giving once again.
Okay. So the thing is like in this question, we had to find out the probability that both the balls drawn are black, correct? So here I'm having the first event, that is my E1 is drawing a black ball in the first draw. E2 is drawing a black ball in the second draw. Okay. Now I have to find out the probability of E1 intersection E2, that is both of my balls are black. So it would be equal to the probability of getting a black ball in the first draw multiplied by probability of getting a black ball in the second draw, given that I got my first black ball in the first draw. This is my partial information. Okay. According to this condition, I am getting my second ball as a black ball. Got it?
Yes, ma'am.
Everyone? This multiplication rule is clear to everyone?
Yes.
Sure. Shall we proceed further? Shall we?
Yes.
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 Okay. Now the third is independent events. Okay. So
Are we discussing week 8?
yes.
Oh, thank you.
Okay then. Now we are having independent events. So basically, if I want to ask like if my probability of E given F is equal to probability of E, that is if my let's say if my conditional probability is equal to my unconditional probability of E. Okay. So let's say I'm taking an example. Okay. I'm tossing a coin 2 times. So my sample space would be HH, HT, TH, and TP. This is my sample space. Okay. Now I'm considering an event E, which is that in the first toss, I'm getting a head, and F is in the second toss, I'm getting a head. Okay. These are my events. Fine. Okay. So in the first toss, the probability of getting a head is 1/2. And in the second toss, the probability of getting the head is 1/2. Is it fine? Like,
Yes, ma'am. Yes, ma'am. We're following.
yeah. Okay. So basically, if I see, so if I need like the probability of E given F, what does it mean? That given that my let's say this is
Ma'am, like E doesn't depend on the occurrence of F. Is that what you mean?
yeah. So basically, if I have to find out probability of F given E, or let me just change this. Okay, just a second. Let me just change this one. This is my F and this is my E. Okay. So if I have to find out the probability of E given F, this is basically that in like it is what is the probability of getting a head in the second toss, given that in my first toss it was head. So basically this would be equal to
1/2. Again,
it would be
1/2.
1/2 only, correct? And now probability of getting head in the second toss is also equal to 1/2 only.
Yes, ma'am.
Correct. So if we see here, the probability of E given F is equal to probability of E only.
Yes, ma'am.
Okay. So this will, what it will show that the unconditional, the conditional probability of E given F is equal to the unconditional probability of E. That means it is not depending upon F.
Yes, ma'am.
So,
Okay.
just one question. So, how is P E given F is 1/2? It should be 1/4, right?
It should be
1/4, right?
But there are two results with head being first, HH and HT. That's why.
But we are also taking into consideration that E is E intersection F is also there, right? So when F has already occurred, so given that F has already occurred, we are given that E has already occurred, F occurs, right?
no
So
F has already occurred. Given
Yeah.
F, you have to find out the probability of E.
Yeah. So only HH remains. This there will be only one
yeah,
one
but
term, right?
but E does not depend on F. That is what the point is. I think that's why it's
I
on.
think it depends on F because we are stating that F is heads in the starting case. So H only should be the case, right?
Yes. Yeah, that's why you are saying that given F has already occurred, so F must have been an H. So given that the second element is H, the second term is H, so the first term should be H only. So only the first entry, which is the HH, should be allowed, right? So
Yeah,
we are
but
not
See,
counting.
just a
you
second.
have to divide by the total.
Probability, see, the probability of E given F is probability of E intersection F upon probability of F.
Yes.
So probability of E intersection F is 1/4
Uh,
and probability of F is 2/4.
oh, it's okay. It's coming to be half. Okay.
Now fine.
Yeah, it's fine.
Yeah. Okay. So from both of this equation, we see that probability of E given F is equal to probability of E. That means my occurrence of E is not depending upon the occurrence of F. Correct?
Yes.
That means my E is independent of F. We can say that. So now if,
Yes.
so basically my, if I see my multiplication rule, it was E intersection F was probability of F into probability of E given F. So if my F is E is independent of F, so I can write this as probability of E given F. Can I write it as probability of E?
Yes.
So this is my rule of independence. So if if probability of E intersection F is equal to the product of probability of F and probability of E, we say that E and F are independent.
Ma'am, 1 second, could you just go through the question, ma'am?
Question, which question? This one, example. Hello. Hello. Who's asking the doubt? Okay then. So is this thing clear? So we can say that two events E and F are independent when, if and only if the probability that both occur will be equal to the product of their individual probability. Got it?
Yes.
Yes.
Okay.
Yeah.
And
This seems fine. Yeah.
this is fine. You were asking any other doubt? Like you were asking some question.
No, I think not me, I guess.
Yeah, I was asking about this question once. Could you explain why HH, like,
Just a second. Just
how are they independent?
hello. Hello.
Yes, ma'am.
Yeah.
Yeah.
Yeah. Sorry for the disturbance. Okay. So yeah, somebody was asking me something.
Ma'am, could you once again explain the question, the previous question which we were discussing? This question.
This example only, right?
Yes.
Okay. See, I'm having I'm having a coin. I'm tossing it 2 times. So this is my sample space. Okay. Now the thing is like my F event is denoting that my in the first toss I'm getting head, and E is the event I'm getting a head in the second toss. Okay. Now the probability of E given F is equal to probability of E intersection F upon probability of F, which is 1/4 upon 2/4, which is 1/2.
Yes,
Right?
ma'am.
And probability of E is also 1/2, which is getting a head in the second toss. So it is basically like getting head. So if I'm tossing in the second toss, I'm having a sample space H comma T. So what is the probability of E? It would be equal to 1/2 only.
Yes, ma'am.
Correct? So if you see here, the probability of E intersection F is equals to 1/2 and probability of E is also 1/2. So we can state that like my F is independent of E, like the occurrence of E is not depending upon the F. We can say that because the
Ma'am,
probabilities
I
are
feel
same.
it is dependent, right? Since
Hmm?
first should be the first case should be compulsory having a head, right?
Hmm.
I am
No,
convinced.
the probability is same only, right? The probability of E given F and probability of E is same. So we can say that the occurrence of F does not depend upon, the occurrence of E does not depend upon F only. So if I'm getting F as a tail or a head, the probability would be same only.
Okay, ma'am. Yeah.
Got it?
Yes,
So this
ma'am.
is my independent. So we can say that the two events E and F are independent when my probability, like the probability of occurring, both occur is equal to their multiplication of their individual probability. Got my point?
Yes, ma'am.
Everyone?
Yes, ma'am.
Okay. So, okay, let's take an example. Okay, I'm rolling a dice twice. Okay, so I'm having some sample space which are like 36 samples. Okay, now I am having three events. Even, which is the first outcome is 3. Then E2, which is the sum of outcome, sum is 8, and E3 is that the sum is 7. These are my three events. Fine. Now, if I'm asking you, like you have to find out whether my E1 and E2 are independent. How will you find out? Which is that the probability of E1 intersection E2 should be equal to probability of E1 into probability of E2.
Yes, ma'am.
Correct? Okay. Now, let's find out the probabilities first. So E1 intersection E2, which is that the first should be 3 and the sum should be 8. So what is the case? There is only one case only, which is 3, 5.
Yes, ma'am.
Yes,
Okay. So this is basically 1 by 36.
Yes, yes, ma'am.
yes, ma'am.
Okay. Now, probability of even. What is even? Even is like the first should be 3. So it is going from 3, 1 to 3, 6. So this will be equal to 6 by 36.
Yes, ma'am.
Okay. Now, and probability of E2. What is E2? That the sum should be 8. So there are how many cases? 2, 6.
5 by 36.
Okay. So this would be equal to 5 by 36. Now, put this all value here. So first of all, this probability of even intersection E2 is 1 by 36. Let's multiply these values. So this would be equal to 6 by 36 into 5 by 36. So if you see here, this is not coming out to be 1 by 36, right? So we
Yes.
see here that the probability of even intersection E2 is not equal to probability of even into probability of E2. So we say that E1 and E2 are not independent. Fine?
Yes, ma'am.
Okay. Now if you have to find out whether my if my E1 and E3 are independent, that is probability of E1 intersection E3 should be equal to probability of E1 into probability of E3. Correct? Now, what is my probability of even intersection E3? So even is that the first toss should be, sorry, the first rolling of die should be 3 and E3 is that the sum should be 7. Correct? So what is the case? There is only one case which is 3, 4.
4. So it's
So
1
it
by
will be
36.
1 by 36. Now, probability of even is 6 by 36 and probability of E3, sorry, E3 is, so how many cases are there that the sum should be 7? So in
Ma'am.
total, I'm having 6 cases.
Yes, ma'am.
Yeah.
Okay. So it would be 6 by 36. So, okay. Now, probability of E1 into probability of E2. It would be equal to 6 by 36 into 6 by 36.
I think it should be 3, right?
3, ma'am.
It would be 1 by 36, sorry. So if you see here, my probability of even intersection E3 and probability of even into probability of E3 is also 1 by 36. So this is coming out to be equal. So we can say that my even and E3 are independent.
Here. So P1 times P3 is 1, right?
Hmm?
Okay. It's okay. It's 1 by 36. Yes.
Fine. Now you know how to calculate, like how to find out if they are independent or not.
Yes, ma'am. Understood.
Understood? Okay. Now, we are having one property of independent events. So the first property is if E and F are two events and they are independent. Okay. So can I say that E and complement of F, are they independent?
Yes.
They are independent. So basically, if my E intersection F is equal to probability of E into probability of F, correct?
Yes, ma'am.
This is the case. This is the case when E and F are independent. Now we have to find out whether my E intersection F complement is equal to probability of E into probability of F complement. Okay, we need to find out this value. Fine. Okay then. So we are assuming that my E and F are independent. Okay. So if I draw the Venn diagram, so this is my E and this is my F. Okay. So like they're independent, right? So if I have to calculate probability of E, so this is my probability of E intersection F. Sorry. This is my E intersection F, this one. And this is my E intersection F complement,
Yes, ma'am.
correct? So if I have to write probability of E, this would be equal to so my E would be equal to E intersection F union E intersection F complement. So E can be written as E intersection F union E intersection F complement. Can I write it?
Yes, ma'am.
Okay. Now, if I put the values of probability here, okay. Now I said like in earlier case that E and F are independent. Okay. So I can write E intersection F as probability of E into probability of F. Correct. And I'm saying that my E intersection F and E intersection F complement are mutually exclusive. So I can write probability of E equals to probability of E intersection F plus probability of E intersection F complement. If they're mutually exclusive, I can write this.
Yes,
Yes,
ma'am.
by the addition
Okay.
rule, right?
Yeah, correct. So this would be equal to probability of E intersection F complement, right? Now I can write this as probability of E minus probability of E into probability of F equal to probability of E intersection F complement. Now probability of E is common. So this would be 1 minus probability of F equal to probability of E intersection F complement. Right? So this would be 1 minus, so this 1 minus probability of F is equals to probability of F complement only. So I can write this as probability of E intersection F complement is equals to probability of E into probability of F complement. So we see here that if my E and F are independent, then my E and F complement will also be independent. Is this proof clear to everyone?
Yes, ma'am.
Sure.
Sure.
Okay. So if so the condition is if I'm having three events, E, F, and G, I say that these are independent if and only if the first thing is that the probability of E intersection F intersection G should be equal to probability of E into probability of F into probability of, just a second, just hold a second. Okay, so E, F, and G are my three events. So I say that they're independent if the first case is if my probability of E intersection F intersection G should be equal to the product of their individual probabilities. Secondly, probability of E intersection F should be equal to probability of E into probability of F. Third, probability of E intersection G should be equal to probability of E into probability of G. And fourth, probability of F intersection G should be equal to probability of F into probability of G. So these are my four conditions. So I say that these three events are independent when the probability that like they all occur should be equal to the product of their individual probabilities. So we have to take the three cases, then we have to see whether like individual cases also, like whether E and F are also independent, E and G are also independent, or F and G are also independent. So these are the four conditions that you have to see to check whether E, F, and G are independent or not. Is it clear,
Yes, ma'am.
everyone?
Yes, ma'am.
Okay. So till here, is it fine? Like independent multiplication rule, the conditional probability, these three topics are clear to everyone?
Yes,
Just
ma'am.
one question, what would have happened if we wouldn't claim that this E and F might not have been mutually exclusive?
They have to be, if they are in, if they have to be independent, they should be mutually exclusive. Okay. Now the last topic is Bayes. Okay. So before that, the thing is we have to know what is law of total probability. So so if I'm having two events, E and F, okay. So if I make the same graph, okay, this is my E and this is my F. So I can express E as E intersection F union E intersection F complement. Correct?
Yes, ma'am.
Okay. Now, probability of E is equals to probability of E intersection F union probability of E intersection F complement. Okay.
Ma'am, can I ask a certain doubt about this happening of the mutual exclusive events? So when we are talking about these mutually exclusive events, this means that these two events are disjoint events, right? So essentially, if these two events are disjoint, then we are not supposed to have an intersection of these two events, right?
Like, yeah, no, like intersection of, like, let's say if my E and F are mutually exclusive and disjoint, so my probability of E intersection F would be equal to 5.
Yeah, okay. Yeah, yeah. And in this case, when we look for this, deduce the expression for this E and F being independent, we use the same rule where we found that this E intersection F, but just a moment, like when we're talking about these two being mutually exclusive, but in our case, P of E intersection F was not a null set. We were taking this P of E intersection F as it was, right? Because E intersection F would have been null set. So P intersection of F should have been 0, right?
It is not equal to 0. It is basically a null set. Like it is equal to 5. Like there is no common point or no common event occurring between them.
Yeah, I'm just asking about this P of E intersection F. That is 0, right?
It is not equal to 0. No. You can't say it is equal to 0.
Okay.
Okay. Okay. So probability of E is equals to probability of E intersection F union probability of E intersection F complement. Okay. Now I can write this as probability of F into probability of E intersection F plus probability of F complement into probability of E given F complement. Can I write this?
Yes, ma'am.
This is basically what? This is my multiplication rule,
Yes.
correct? If I have to find out the intersection between two events, I can write this as if I have to find out probability of E intersection F, it would be equal to probability of F into probability of E given F plus probability of F complement into probability of E given F complement, right? So I can say that each conditional probability, like it is weighted by the probability that the event on which it is conditioned, or we can say that the probability that the event E has occurred is equal to the weighted average of the conditional probability of E when F occurs, and the conditional probability when F does not occurs. I can write the probability of E event like that.
Yes. This follows from the multiplication rule. The first term. Yes. And the second term also deduces from that itself. And then we are talking about these two events again being mutually exclusive, right?
Okay. So, yeah. So this is my law of total probability. If I have to find out the probability of E event, I can write it as the weighted average of the conditional probability of E when F occurs and when F does not occurs. Okay. So if I am having events like, let's say I'm having E1, E2, I'm having K events, okay, which are mutually exclusive. Okay. So if I have to find out the probability of E, it would be equal to probability of F, let's say, sorry, this is F only. F1, F2, F3. Okay. So if I have to find out probability of E, it would be equal to probability of F1 into probability of E given F1. Okay. Plus probability of E given F2 into probability of F2. Similarly, this will go up to probability of Fk into probability of E given Fk. If I take like K general cases there. So this is actually my law of total probability. So if I have to find out the probability of E, this would be equal to the weighted average of the conditional probability of E given F, if my F occurs and if my F does not occur. Like the different cases you can see.
I have an example to talk about. Say, for instance, we think about these mutually exclusive events are those that do not occur at the same time, right? But for example, say when a coin is tossed, then the result would be either a head or a tail. But we cannot get both the same results at the same time, right? but for that but for let's say we are taking the following example.
See, mutually
Like
exclusive is like the occurrence of like the first thing, the occurrence of one event should not, what's that word? Like it should not
disturb the
depend
other.
upon the occurrence of the second event.
Yes. See, in principle, we should have any. So E intersection F would be null set, right?
Hmm.
So but in the previous case, when we deduce this expression, and here also when we are looking for this base rule, we are making a statement that E and F are being mutually exclusive, right? But we are also it also appears
ENF,
that
just a second. No, the
because if the first doesn't hold, then this E intersection F, I mean, can you go to the second line? This P of E equals the product rule. The second term in the product rule wouldn't hold, right? If those two aren't mutually exclusive.
just a second. Can you repeat once again?
Yeah, I mean that when we talk about this base rule, the first thing that comes into mind is, so when we are talking about this E and F being independent events, we found that these independent events are such that there would be no element in E intersection F. So intersection F would be a null set, right?
Okay. Okay, yeah, you're correct. So basically this, okay. So here my E and F are not mutually exclusive actually.
Okay. So, but then how you're writing the second term? I mean,
So basically it's a multiplication rule, right? So if okay, so my conditional probability was E intersection F is equals to probability of E intersection E given F is equals to probability of E intersection F upon probability of F, right?
right, right.
So if I have to find out this intersection, I would just be multiplying this conditional probability with the probability, right? The probability of F.
Yeah, but when remember, like when we are deriving this in the first step, like in when we're talking about these independent events, we made this claim that E and F should be mutually exclusive, and then only we could write this P of E equals P of E intersection F union of P of E intersection F complement, and thereby we introduce this product rule again, right? And then we introduce this product rule into the first expression on the first principles.
In the first case, we took E intersection F and E intersection F complement as mutually exclusive events.
Okay.
Not E and F. This event
Okay.
and this event.
Okay.
Yeah.
Okay. Okay. Mm-hmm. Okay. Thanks. This makes sense.
Now it's fine.
Yeah, it's fine.
Okay, so so this is the case. So this is how I can write the probability of E as probability of F into probability of E given F plus probability of F complement probability into probability of E given F complement. So if I'm having F1, F2 mutually K mutually exclusive events, then the probability of E would be equal to, I can write this as summation of K going
You're going
I
from 1 to n,
no
maybe.
I
Okay.
it would be I
Okay.
equals to 1 to K probability of
Okay.
Fi into probability of E given Fi. So this is the law of total probability. Okay. So let's take one example here. Okay. This is one example here. Can you see the question? Okay. So I'm having an insurance company An insurance company believes that the people can be divided into two classes, those who are prone to have accidents and those who are not. Okay. So the data indicates that an accident-prone person will have an accident 1 year period with probability of 0.1. The probability for all others is 0.05. Okay. So we are having two classes, the people who are prone to have accidents and who are not. And the data states that the person will have an accident 1 year period with probability of 0.1, and the probability for all others would be 0.05. Okay. Now, suppose that the probability is 0.2 that a new policy holder is accident prone. Okay. So, which is equal to 0.2. So now you have to find out the probability that a new policy holder will have an accident in the first year. Just read the question once again, everyone, and tell me if you are having any doubt in the question. We will solve it, but just read the question once again. Have you read the question?
Yes, ma'am.
Okay. Okay. I'm taking E as an event. Okay. My E event is that the new policy holder will have an accident in the first year. Okay. This is my E event. And I'm taking F as the new policy holder is accident prone. Fine. Now, according to the question, if we see here, an accident prone person will have an accident. So basically that person is accident prone and he will have an accident 1 year period. The probability is 0.1. So I can write it as probability of E given F as 0.1, that he is an accident prone, and E is the event that he will have an accident in the one year period. So this is basically 0.1. Is this clear?
Yes, ma'am.
Okay. Now, can I write probability of E given F complement as 0.05? Because for others, what do you mean by others? That means the people who are not accident prone, for them, they will have an accident 1 year period would be equal to 0.05.
Yes, ma'am.
Correct? So probability of E given F and probability of E given F complement. Are these probability clear to everyone?
Yes.
Now, the thing is, now the second thing is that we have been given is that the probability is 0.2 that a new policy holder is accident prone. That means we have been given probability of F as 0.2.
Yes, ma'am.
Okay. Now, the question is we have to find out the probability that a new policy holder will have an accident in the first year. So basically, we have to find out probability of E. This is what is E? E is the probability that the new policyholder will have an accident in the first year, right? So we have to find out the probability of E.
Yes, ma'am.
So according to the law, it will be equal to probability of F into probability of E intersection F plus probability of F complement into probability of E given F complement.
Yes, ma'am.
Is this thing clear to everyone? Can I hear any more?
Yes, ma'am.
Sure. Okay.
Yeah.
Now, so probability of F is equal to 0.2 into probability of E given F is 0.1. Okay. Similarly, probability of F complement. What is probability of F complement here?
0.8.
0.8. So this would be 0.8 into probability of E given F complement. It would be 0.05. Correct? So if you solve this, you will get 0.06. Okay. So this is the probability that a new policy holder will have an accident in the first year. Got the question? Got the solution? How to calculate it?
Yes, ma'am. Because we're
Everyone,
using the law of total
total
probability here.
probability. Correct. So here basically I'm calculating the probability of the people who are having accident in the first year. So there can be two cases in which like they're accident prone, okay, and when they are not accident prone. So I'm having two cases. So basically, if you see here, this was the probability, right? I'm having probability of ES, probability of F, probability of E given F, plus probability of F complement into probability of E given F complement. So it is the conditional probability of E when F occurs and when not F occurs. Got my point?
Yes.
This is the same situation. When it is accident prone, when the person is an accident prone person, or he is not an accident prone person. So we are taking these two conditions. Got my point?
Got it, ma'am.
Yeah, okay. Now this is the law of total probability. Then comes the Bayes rule. Okay, so what is so let's suppose uh, I have to calculate probability of F given E. In earlier cases, we were finding out probability of E given F, correct? Now we have to find out probability of F given E. So this would be equal to probability of F intersection E upon probability of E.
Yes, ma'am.
Okay. Now probability of F intersection E, I can write this as probability of F, probability of E given F.
Yes.
Okay. And probability divided by probability of E is equals to probability of F into probability of E given F plus probability of F complement into probability of E given F complement. So this is my Bayes rule. Everyone got the formula?
Ma'am, so the denominator is basically OPLV. Okay, yeah.
So probability of E, this is my total probability, and this is my intersection. So this is from the multiplication rule, and this is the law of total probability. We have just divided it. Just put the formula on. Is this fine?
Yes, ma'am.
Okay. Now, if you see in this question, so if the thing is like, if I have to find out like okay. Now, if I have to find out that the new policy holder has an accident in the first year, it is given that he had an accident in the first year. Okay. Now you have to find out that what is the probability that he or she is an accident prone. So basically, I have to find out probability of F given E. It is already given that the new policy holder had an accident the first year. Now I have to find out the probability that he or she is from the accident prone. Got the question?
Yes, ma'am.
So now I can write this as probability of F intersection E given probability of E. Right? Now,
Yes.
probability of F intersection E can be probability of F into probability of E given F upon probability of E. Now, according to this question, probability of F was equal to 0.2.
Yes, ma'am.
Okay. So this is 0.2 into what is probability of E intersection F? It was basically 0.1 upon. We calculate the probability of E, it was 0.06. So if you calculate this value, it would be 0.02 upon 0.06, which will be equal to 1/3. So this is my probability. So we can say that given that the new policy holder had an accident the first year, the conditional probability that the policy holder is prone to accident is equal to 1/3. Got the solution,
Yes, ma'am.
everyone?
Yes.
Sure. The base rule, the law of total probability, conditional probability. Okay, let's go through the formula only. Okay, shall we? Let's go through all the formulas.
Yes, please.
Okay, so the first thing is the conditional probability. So if I'm having two events, E and F, so probability of E given F would be equal to what? Probability of E intersection F upon probability of F, right?
Yes.
Okay, then we have multiplication rule, which states that probability of E intersection F would be equal to
Probability of E
Probability
given
of
F
E given
times
F,
10 E of F.
probability of F.
correct. Now third, we have independent events. So if I'm having two events, E and F, so I can say E and F are independent when, if and only if, my probability of E intersection F is equal to
Probability of E, product of
E
probability of F.
into probability of F. Then the fourth point is my law of total probability, which states that probability of E is equals to probability of F into probability of E given F plus probability of F complement into probability of E given F complement. So the occurrence of event E is equal to the weighted average of conditional probability of E when F occurs and when F does not occur. Fine.
Yes.
Okay. And the last thing is the Bayes rule. So if I have to find out probability of F given E, it would be equal to probability of F intersection E divided by probability of E, or I can write this as probability of F into probability of E given F upon probability of F into probability of E given F plus probability of F complement into probability of E given F. So these are some of the things that you should remember. The formulas, what is conditional, multiplication rule, independent, law of total probability, and Bayes rule. Is this fine to everyone?
Yes, ma'am.
Yes, ma'am.
Sure, the theory is fine. Have you been through week 8 lecture? Have you
Yes,
gone through
ma'am.
that?
Yes, ma'am.
Okay then. So just go through it once again, solve the questions and all. So on Tuesday, we are having a doubt session, right?
Ma'am, could I ask my PYQ?
Yeah. Okay. So nobody is having any doubt in this theory part, so it's fine.
Yes, ma'am.
Okay then. Yeah. So what's your doubt?
Ma'am, so I sent you the link to the paper in the chat.
Okay.
Can you see it? Should I send it again?
Which which question?
Question 8, ma'am. It's to do with independent events.
Okay. An urn contains card number this. One card is drawn at random. Just the number for the number is given.
Ma'am, so here my doubt was, so I did the calculations and I found that E1 and E2 and E3 are all dependent, but the answer scheme is saying that E1 and E2 are independent, E2 and E3 are independent, but E1 and E3 are dependent. So the options 1, 2, and 5 are correct. But I only got option 5 correct. I didn't get the option 1 and 2 correct. Could you help me with that?
Okay, so what is the total number of um, wh- uh, what are the total number of cards? Like,
I think so. I think there are 401
yeah,
cards.
so in total we have 401.
Can you please share the question at once, or maybe the link?
It's in the link only. Oh, okay,
Ah.
she doesn't. Can you just share this link to
Yes, ma'am.
everyone?
Yes, one. Done.
Yeah, thanks. I got it. Yeah.
Okay, so now even is that the number should be greater than 150 but less than 200, right? So in total, I'm having 50 numbers,
Yes, ma'am.
correct?
Yes, ma'am.
So the total probability of getting even would be equal to 50 by 401, right?
Yes, ma'am. I got that.
Okay. Now event E2.
And so, which
Which
question
is
are we talking about in here?
Question 8.
Question 8. Okay.
So event E2 is the number on the card is greater than or equal to 106 but less than 156. Okay. So
Ma'am,
let's,
so again 50 numbers, I think.
yeah, it's like total 50. So the probability of E2 would be 50 by 401. Then we have having E3. E3 is the number on the card is greater, the number on the card is greater than 60 but less than or equal to 110. Okay, so basically all this is also 50.
Ma'am, but the number of cards only start from 100, right? The number starts from 100. So, like, how can
The number on the card is greater than 60. It is greater than 60, less than equal to 110, right? So 110 minus 60 is 50 only, no?
Yes, ma'am, but the urn contains cards numbered 100 to 100 to 500. So how can there be like cards that are 60, 61, 62? It should only be 100 and above, right? Because initially they say cards numbered 100 to 500.
60 but less than. It is
So just one question about this P of E1. So P of E1, how is it 50 by 401? Because we are supposed to consider all numbers greater than 150, right? But less than or equal to 200.
Yeah, that's 50 numbers.
200
yes.
minus 150, it's
Yeah, yeah,
50.
yeah.
The number on the card is 60 but less than 110.
So then the probability of E3 will be the only possibilities would be 100 to 110, right? So only 11 possibilities are there.
So from 100, it would be from 100 to 115. So basically it is 100. So that your answers are 1.
Ma'am, so for the third one, my answer, the possibilities for E3 are 100, 101, 102, 103, all the way up to
Like there are
110.
10. Yeah. So basically it is like
11, right, ma'am? 11 possibilities.
So this would be 20, 11. So this would be 11 by 400.
Ma'am, is my logic correct, or like is there something wrong?
No, why is E3 11? Because E3 is supposed to be the number on the card is greater than 60 but less than or equal to 110. So it should be 50 again, right?
But the numbers are numbered from 100 above. If you read in the question, it says there, an urn contains cards numbered from 100 to 500. So
Okay.
that's not possible for numbers below 100 to be present. That's why we're only considering.
Okay.
Yeah.
Mm-hmm. Okay. So that thing minus.
So you're counting
Okay.
100, 101, 102, 103, all the way up.
Yeah. Okay. So there are only. Yeah. Okay. So then there would be 11 cards on. Okay.
Yeah.
Okay, let's solve this question. Okay. So now we have to find out probability of even intersection E2, correct? So this is basically even intersection E2 is
basically like the numbers that are.
It should be 151, 200. So there is no common. They don't overlap, right?
Ma'am, for E1,
the number on it is greater than equal to.
I think they intersect because
106. Okay. Greater than 106, but less than 156.
Ma'am, they intersect.
I think there is intersection because you can find a set in from where you have 151 to 155. That
Correct.
would be there.
So there would be, and this is starting from 150 to 200. So basically 150, 150, 156, 106, 150. So even is in the range of even is 151 to 200, correct? And E2 is 106 to 155.
Ma'am, 155 inclusive, I think. Because they're saying less than 156, so 155 should be included in the range.
It's from 151, right?
Yes, ma'am. So the common elements are 151, 152, 153.
152. So there are common 11. Sorry.
And 155 also now, because we're including.
Yeah, it's including also. So there are 5.
Ma'am, so it's 5 over 401, right?
Yeah, this will be 500. But
Yes, ma'am. So now I calculated the probability of E1 to probability of E2. It's not equal to 5 over 401. Clearly,
yeah,
right? So that means these events are not independent. But
correct, they're not independent.
in the mark scheme, it's saying that it's independent. I was so confused. I did the calculation multiple times.
They're let me okay, can you tell me the answer of this? These are the options which are correct.
Option 1, 2, and 5.
1, 2, and 5.
Ma'am, option 5 I got. Like E1 and E3, when you do the calculation, you get that they are dependent. But the E1 and E2 and E2 and E3, I don't know how they are independent.
Okay. So let me solve it.
Okay.
Let me see it. So like day after tomorrow, I'll tell you. Okay. After
Okay.
solving it.
Okay, ma'am. Thank you.
Yeah. Okay then. So okay. So any other doubts? If you're not having any other doubts, so shall we end the meet then?
Ma'am, can you share the PDF what you have wrote right now in the chat box, please?
In the chat box. One second.
Yeah.
Just a second. The example also.
Yeah, what you have written in that white sheet, that PDF.
When will we have the revision for the stat?
The revision would be on 12th.
That's like Professor Herself, right? Is
Ushama.
that the yeah? And that will be the revision from 5 to 8 or 1 to 8?
It would be 5 to 8.
5 to 8. Thank you.
Okay, I've shared the sheet. It's loading. But it would be it would be in the supplementary content also. So you can find the PDF there from there also.
Okay.
So right now I've uploaded it like in the sense like in the chat only. So you can have you released the P have you got the PDF?
No, there is no message. Yeah, we got it.
Got it?
Yeah.
Okay then. So now is it fine? So the week 8 is clear to everyone?
I have basic fundamental doubt. Maybe I'm sorry I didn't ask you because I've been quite bothered here back. When we are talking about the mutually exclusive and mutually independent event, what is the difference there?
Okay. So basically mutually exclusive, what are mutually exclusive events? That like the occurrence of one event does not bother the occurrence of the next event, right?
Okay.
That is mutually exclusive. Independent is basically what are independent events? That the conditional probability of occurrence of one event is equal to the unconditional probability of that event. That is probability of E given F is equal to probability of E only. That is independent event.
Thank you.
Got it?
Yes, I'm getting it. Yeah.
Yeah.
Thank you.
Okay. So yeah. Okay then. So Now is it fine? Shall we end the meet or any other doubts?
It's fine.
With regard to the dashboard, with regard to the dashboard entries and so on related to the course, whom should I, now that I have the access to the discourse, but should I still write to the support for these?
Can you repeat?
I mean, with regard to the dashboard entry discrepancies that we see in the course and so on, like should I, now that I have the access to the discourse, should I write or put it once again in the discourse, or should I write to the support for the dashboard related queries?
That I'm not getting your point, actually.
I mean, the entries, the score entries, whatever is there on the dashboard, whatever that we see on our dashboard, if there is an issue with that, because I see in my case that some entries are missing there.
Okay.
And so should I, because that normally when I write to the DS support, they say that you should actually write to in the discourse about it.
Okay.
But when they come for these kind of the entry, I mean the data entry thing, is it the support that is actually they are responsible, or should I, because they normally say that you talk to your instructor. So you being our instructor, so the case I would like to know if I have an issue, that should I write to you regarding this issue that I'm having a issue with the what you call the entries that are related on my dashboard regarding the
Okay,
course.
just if you're having any like any doubt with this, just write it in the discourse. Okay, just tag the instructors or tag the TAs and all. They will solve the
Okay.
problem. Just
Okay.
yeah, just write your issue in the discourse only, but just tag anyone, like tag any instructors or tag any TA. Then only we will be able to solve your issue, right? If you're not tagging anyone, we won't be knowing what issue you are having, or we won't be getting the notification.
Yeah, and one more thing, like for example, like when I'm trying to tag, for example, like I think in one of the previous incidents, I want to tag the instructors like you and this thing, but whatever the name that we see on the dashboard, like when we try to go to the discourse, we don't see your name. Rather, it's a different thing there. Like how can I mean, I'm trying to locate like about your if I want to tag you in the.
No, like in the discourse only we have written like who are the instructors and who are all the TAs. They have been written.
Oh, is it
If you
so? Oh,
see,
okay, sorry, I missed it somewhere. I'm sorry.
yeah, like in the first or the second, I guess, like in the
Okay,
first,
okay,
first only we have written all the information about who are all the
okay, the
discourse,
course
like
instructor.
instructors and TAs. Yeah, so you can
Okay,
just
okay,
go through that and
okay.
just tag anyone. Okay.
Because I have been trying to communicate with the DS support, and they, I mean, they did say that I mean, they did advise me to talk to the instructors. So
Instructors. Okay.
yeah, so I will tag.
Okay, fine.
I mean, I will
Just
tag the
tag,
instructors
yeah,
and write a
just
mail.
write your any doubt or just tag anyone. Then only we will be able to solve it. Okay. If we are not able to solve it, the TAs will
Okay,
solve
okay.
it. So it will take time,
Huh.
but have patience. Okay.
Mhm.
Yeah.
But when we send a message, I would like to know that, because when in the discourse, like when I'm trying to put anything like kind of open for them, I'm trying to do it, that's fine. But when I'm trying to write a message, it is kind of only it is getting message to all of you, or that is also getting posted on the forum.
It's getting posted on the forum only, the discourse.
Fine. Because I didn't realize that part. Because in my
Hmm.
previous case, I was searching for my message, but I couldn't locate it. Maybe I don't know.
Oh.
Maybe I should have didn't refresh or something of the kind. Okay, I will write to you. I mean, I will post the. I mean, through
Yeah.
Discourse, I will communicate. Thank you so
Okay.
much.
Okay. Okay then. So okay, so let's end this meet then.
Right.
Now
Yeah,
there are no
thank
doubts.
you.
Thank you, everyone. Have a great night.
Thank you. Good night.
Okay. Bye, everyone.